Hello friends, welcome to Sekho. In this video we are going to look at real numbers from a different perspective. I have already told you that real numbers means rational numbers and irrational numbers. Okay, rational numbers are those numbers that can be represented like P by Q, where P and Q, you know those things, and they cannot be represented like P by Q. Now let us take few examples. Okay, let us take few examples like 1 by 3 and maybe 13 by 4 and then 17 by 7. Okay, I have taken 3 rational numbers completely randomly. Okay, now we are going to expand these numbers into their decimal expansion. Okay, so 3 we can write like that: 0, 9, okay, 3, 1, 0, 3, 9, 1. You know all these things, I don't have to do it, but still I am doing for the sake of completion. Okay, you will feel that it is being done, and you should also write on your paper. You should be actively participating in learning. Okay, you have to write sometimes, as much as you can you should write, and you should watch these videos with pen and paper in your hand. Okay, sometimes pause this video and do it yourself, for that is how you will keep yourself active. Otherwise your mind will become passive and you will not get anything, or you will get very little amount of things. But when you will do yourself, you will learn much better. Okay, so this will be 12, 1, 0, 2, 8, 2, 0, 5, 20, and remainder is 0. If we try to do this, okay, let us write 7. Some people love to like this, they write like this, so I am also writing like them. So 2, 14, 3 point, and you get 0. So 4, 28, I'm sorry, 2 and then 0, 2, 14, then 6, 0, 8, 56, then 4, 0, 5, 35, 35, then 5, 0, and then you get 7, 49, then you get 1, 0, and then you take 1 and 7 and you get 3. So you already had 3 here. Okay, you already had 3 here, and again you have got 3 here, so you will write 3, 0, then you will take 4 here and you will get 28, then you will get here 2, 0, then it will keep on like that. Okay, so in the first case, in this case, from the very first step it was 1 reminders, R means reminders, where 1, and it was like that. In this case reminder was like, at first it came 1, then 2, then 0. In this case reminders are a long chain of reminders. At first it was 3, then 2, then 6, then 4, then 5, then 1, then again 3. So this reminders, this is a string of reminder. Let us say this is a string of reminder. This repeats again and again in this case. Okay, so after doing this 3 expansion of 3 rational numbers, we observe 3 things. We observe 3 important things. First thing is, we have taken randomly 3 rational numbers, and what we have seen that they are either terminating. That means they are terminating. They are either terminating. That means their decimal expansion is either terminating. That means in this case the expansion has terminated here. Okay, so either terminating or this expansion is non-terminating, but what you see is that it is recurring, means it starts to repeat, reminders starts to repeat. In this case also it was non-terminating. That means it will keep on like doing like that. It will if we want, we can do like that forever. Okay, it will not end. So it is non-terminating, but it is also recurring. Why? Because this string of reminders repeats again and again. Okay, so non-terminating plus recurring. So either this decimal expansion will be terminating, or they are non-terminating recurring. Okay, this is what we are seeing in the first observation. In the second observation, what we see is the number of strings, number of entries, not strings, entries, number of entries in the string. This is the string of reminders that repeats again and again. This number of entries, that means 1, 2, 3, 4, 5 and 6, number of entries in the string of reminder that repeats again and again will be less than the divisor. So here divisor is 7. So if the number is non-terminating, you will see that the reminders repeat, but in that reminders string, which is repeating again and again, you will see the number of string is less than divisor. In this case, number of entries in this string is 6, and 6 is less than 7. In this case, you see that only 1 is repeating, and in this case the number of entries in the string is 1, and 1 is less than 3 because divisor is 3. Okay, so this is what we observe. This is our second observation. Now let us go to third observation. Let us change the color also. Third observation. In the third observation, what we see that as reminders, a string of reminder or a single reminder starts to repeat after certain steps. Similarly, we can see that a block of numbers, block of digits in the quotient also starts to repeat. In this case, this block, that means 428571 will repeat again and again. Okay. So in quotient also you see that block of digits starts to repeat when remainder repeats. These are very simple observations, isn't it? Reminders repeat, nothing very big. I think this one is new to you, and everything else seems quite, and this is also quite interesting, and it seems quite obvious. It has to happen like that. Now, okay, based on these observations, we are going to conclude two things. Number one, if we expand any rational number into its decimal expansion, the expansion will either be either be terminating, 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 or case number 2, it will be non-terminating, 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 but it has to be recurring, recurring, recurring. Okay, so in this case we have only taken 3 examples, and we are actually saying that this is true for any, this is true for any irrational rational numbers, any rational numbers. In case of, take any rational numbers, maybe 7, 7, 8, 9 by 8, 3, 7, whatever you take, it will be either terminating or non-terminating recurring, because it is rational number, it is written like P by Q. It has to be either this one or this one, either this case or that case, it will become like that. So this is our conclusion. Okay, very big conclusion. We are not proving this, just we have observed 3 examples, and we can do few more. You should do few more examples by your own, and you should convince yourself that you take any rational number like this, and it will, if you expand this into its decimal expansion, you will see that it will either be terminating, or if it becomes non-terminating, it will certainly become recurring. Okay, you can see that. So it is very interesting. So based on this, we can define rational numbers like this. Okay, if any number in its decimal expansion becomes, in its decimal expansion becomes terminating, or non-terminating, recurring, then this number will be, will be a rational number, So actually what we have seen, we have actually taken rational number and then we expanded it into decimal expansion, and we are actually claiming the reverse here. Okay, that these if it becomes, its expression decimal expansion becomes terminating or non-terminating but recurring, then it will be rational number. Now let us see whether it is true or not. Let us take few examples. Let us say that this is a number 0, 1, 2, 5. Can we write this number like this is terminating? This is terminating, isn't it? This is terminating. Its decimal expansion is terminating. Can we write like P by Q? Yes, we can write this as P by Q. Very easy, 1 to 5 by 1000. Now can we write any number? Can we write any number like non-terminating but recurring in this form? Let us take any random example like 27, 27, 27. It will go on like that. It is non-terminating but recurring. This block is repeating again and again. So this is non-terminating plus recurring. Can we write this as P by Q? Let us see whether we can do it or not. Okay, so let us say that x equal to this, x equal to 0.27 and dot 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 dot. We multiply both side by 100. We multiply both side by 100. Then 100x equal to 27.272727, and it will go on like that. So we can write right hand side like 27 plus 0.272727, and it will go on like that. So you can see that this is nothing but 27 plus this is again x, isn't it? This is again x, so we can write x again. So 100x equal to this. So if we subtract x in both side, we get 99x equal to 27, or we get x equal to 27 by 99. So this number x can be written like 27 by 99. So if it is surprising for you, then please try to expand this in its decimal expansion, and you will see that you will get this. You should do it by yourself. Okay, I am going to now solve the examples that are given in your textbook. I am trying to follow a textbook, and I am encouraging you to follow textbook, because finally you have to become self learner. You have to know how to read books and understand books by yourself. Okay, that's why I am trying to train you to follow books. Okay, so that after reading books you can understand everything by yourself. Okay, you have to become self learners. Let us try to solve this example. Example 6. They have given a number, and they are saying that show that this is a rational number. How will you do? Okay, this is terminating, so you just write 1, then 1 2 3 4 5 6 zeros, because after decimal point there are 6 digits, so write 1 and then 6 zeros, and you get this number as p by q. So this is a rational number. Okay, this is a rational number. So very easy. Example 6 was very easy, isn't it? Now let us go to example 7. Example 7 is 0.3333. so you can write this like 0.3 and bar. Bar means this number is repeating again and again. Okay, so let us do this. You take this as x. I have already shown you once another example, but let us do it by ourselves. Okay, it will keep us focused and it will keep us active. So they have given 0.33333. This is very easy. We take x equal to this, we multiply by 10 in the both side, so 10x equal to 3.33333, and like that it will go on like that. Now in the right side we can write it like 3 plus 0.33333, like that. So 10x or let us say or 10x equal to 3 plus x. So subtract both side by x, so you will get 9x equal to 3, x equal to 3 by 9, that means 1 by 3. Okay, so we have done example 7. Example 7 is very easy, we have done it. Now example 8, 1.272727, we have to express it in the form of p by q. Okay, let us do by ourselves. You should do yourself, you should have pen and paper when you are watching these videos. You can pause this video and you can try to do it by yourself. Let me change the color once again. So the example was, I don't remember, but maybe it was like 3.27, 27, 27, 27 and like that. So let us take this as x equal to this. Okay, we can write this. Okay, after 27 is repeating, so we have to multiply by 100. Okay, by the way, you can write this number like 3.27, you know this, and bar over this, that means 27 will repeat again and again. Anyway, now you have to multiply by 100 in the both sides, so you get 327.272727 and dot dot dot. So you can write this like this, 327 plus, okay, no, so we will write it like, we can write it like this, but this will not be useful, so we will do something else. What we will do, we'll write it like this, 324 plus 3.272727, because we want to get again this same expression. Okay, so 100x or 100x equal to 324 plus x, because this is same expression like this, so we can write 99x equal to 3 to 4. So x equal to 3 to 4 by 99. So example, what was this example? This example is example 8 is also done. Okay, let us do another problem like 0.2363636 dot dot dot, like that. Okay, so you take x equal to this, so you multiply by 100, so 100x equal to 23.636363 and so on. So you can write this like this, 23.3 plus 0.2363636 and so on. So it becomes 100x equal to, or 100x equal to 23.3 plus this is same like this, so this is x, so 99x equal to 23.3 or x equal to 23.3 by 99. You can write this like 23 by 10 into 99, or you can write this like 233 by 990. Okay, so this was also very easy problem. Okay, so we have done all the examples.